All right, y'all. So this is 4B, second section. And so we're going to talk about some vocabulary and then start adding on to complexity a little bit. So mutually exclusive. So when we have something that is mutually exclusive, this means that the events, oops, didn't mean to do that. Events can't occur together. Mutually exclusive means all by itself. So when two events have no outcomes in common, we refer to them as mutually exclusive events. So, for example, if I have the probability of A and B happening, it would be 0. So what this is saying, if they're this is if they're mutually exclusive. So that and, it means it's going to happen at the same time. Happens at same time. Okay, so for example, if I said probability of, we're going to roll a 6 and 4 on one dice. Well, I can roll a 6 and I can roll a 4, but I can't roll them at the same time, not on one dice in one roll. So these would be mutually exclusive. And we would say that our probability on this is going to be 0. I can't do both. Now, I could roll a 6 and then I could roll it again and roll a 4, but I can't roll a 6 and a 4 on one roll. Okay? Now, what's the probability of A or B happening? So this would be the probability of A or the probability of B. And the difference here is probability of rolling a 6 or a 4. So if I did that, I would have the probability of, let me change my colors here. Could roll a 6. So I would have 1 6 out of 6 options on my dice, plus 1 4 out of 6 options on my dice. So this would be a probability of 1/3 or 0.33. So what happens when we have this or is that this or can tell us it can be either or both. It can be either event or both events. So let's look at an example here. So if I have this rolling 2 dice, so that's what I did up here, rolling 1 dice, we are going to have these different numbers that are in this table. And so what I'm looking at is probability of A, which would be rolling a sum of 5, and probability of B, which would be rolling 2 even numbers. Are these 2 events mutually exclusive? So if I want to look at this, rolling a sum of 5, and these are the values that I roll. If I roll a sum of 5, I could have this as an answer, or this, or this, or this. And then the next question says, what if we want to roll 2 even numbers? So if I roll 2 even numbers, I could have a 2 and 2, 2 and 4. So I could come down here and I would have 2 even numbers, and then 6 and 2. So those would be all of my options. So the question says, are these mutually exclusive events? And in this case, yes, they are mutually exclusive because no events are common. I have my green circles here that indicate rolling a sum of 5. I have my highlighted values here, which indicate rolling 2 even numbers, and none of those are mutually exclusive. So probability of A, which was rolling a sum of 5, I would have 1, 2, 3, 4 options out of 36 total rolls. So if I look at that, 1/9 would be 0.11. If I look at the probability of B, rolling 2 even numbers, I would have 3, 6, 9. out of 36, which is 1/4, which is 0.25. So now this question says, what is the probability of A or B? So remember, this or means I have the probability of 0.11 plus 0.25, which equals 0.36. Now, I could have also kept this as a fraction, right? I could have said the probability of A would be 4/36, plus the probability of B, which would be 9/36. And if I do 13/36, I get 0.361. So it's just a little bit more precise because I rounded. Okay? Now, here it says, identify the following events are mutually exclusive. If they're not, give an example of where they overlap. So we're still using the same table that we have up here, okay? So this says the probability of rolling a 4 and rolling doubles. So doubles would be like 2 plus 2. Well, 2 plus 2 would be 4. So in this case, 4 equals 2 plus 2. So this would be not, oh my goodness, mutually exclusive. All right, so rolling an odd sum and rolling a 3. Well, rolling a 3, I could have 3, and rolling an odd sum would be something like 3 plus 2, which would be 5. Okay, so if I roll an odd sum and I had a 1 plus 2, this would be 3. Rolling a 3, I could get a 3. So this is not mutually exclusive. Okay, rolling a 4 and rolling a sum of 12. So if I roll a 4 and I try to roll a sum of 12, then this would be, I don't know, 3, well, that wouldn't work. I would have 6, well, my sum of 12 is just going to be 6 plus 6, which is not a 4, so this is mutually exclusive. Okay, rolling an odd number and rolling a sum of 10. So a sum of 10, I could have 5 plus 5, and those are both odd numbers. So 5 plus 5 and an odd number, this is not mutually exclusive. Okay, so you're just identifying if what I do in both of these can be repeated, then it would not be mutually exclusive. Okay. All right, so we got our table back here. So find the probability of rolling doubles or a sum of 6. So if I'm rolling doubles, I'm going to make this my blue one. If I'm rolling doubles, it would be 1 and 1, 2 and 2, 3. Those would be my doubles. Okay? Now this says rolling a sum of 6. So a sum of 6 would be this group. So are these mutually exclusive? And this would be no, because I can roll a 3 and 3, and that is going to be my doubles, and that is also going to be my sum of 6. So these are not mutually exclusive. So if I look at this, my probability of A, rolling doubles, would be 1, 2, 3, 4, 5, 6 out of 36, and my probability of B would be 5 out of 36, rolling a sum of 6. So the probability of A and B, so this would be together, the probability of both of those, I only have one option, and that's right here. So that would be 1/36. So the probability of A and B happening together only happens one time. But the probability of A or B would be 6/36 plus 5/36, which is 11/36. But we have a problem. When I counted all of these, I counted this middle number, And when I counted all of these, I counted the middle number. So I have to subtract 1 over 36, and this gives me 10 over 36. Now the reason why I subtracted this is because otherwise we would count it twice. I counted on my probability of A, I counted on my probability of B. So I have to subtract it one time. So when we have events that overlap, adding their individual probabilities count the overlap twice. So we have to subtract one of the overlaps so that it only gets counted once. We call this the addition rule. So our general addition rule is going to be the probability of A or B, and this is going to be the probability of A plus the probability of B minus the probability of A and B. Now, this is what it says. This is what we need to know, but I'm going to give you another little nomenclature thing that we're going to shift into. We're going to shift this OR into a union, and a union is just a U. And we're going to shift this AND into an upside down U. And so here's how I remember this. If you look at the word AND, we have the N that's in the middle, and it looks like this upside down N. Okay, so that's just an easy way for me to remember that AND equals this upside down end. Okay, so it says, notice how if A and B are mutually exclusive, so if they're mutually exclusive, that means they're independent, then the probability of A and B is 0. They can never occur at the same time. So here, my probability was 1 over 36 because they can occur at the same time. But if I look back over here, the probability of A and B, in fact, I didn't even calculate it, but the probability of A and B happening is 0 because they never overlap. Okay? And then the probability of A or B is the probability of A plus the probability of B. Okay? So this is what happens when it's mutually exclusive. So how do we know if we have this value of A and B? So for now, we're just going to use common sense, and we're going to draw the sample space, or we're going to look at the sample space, but here in just a minute, we're going to get to this general multiplication rule. So right now, if we look at this, it says a card is selected from a random deck of 52. And y'all, I know some of you don't play cards, but you've got to know what a deck of cards looks like, and that's what this is. This is a picture for you. If you are not a card player, you've got to know there's 4 suits: clubs, spades, hearts, diamonds. This is not a 1. This is an ace. And then we go 2 through 10, and then we have Jack, Queen, King. And these 3 are called your face cards. Why? Well, they have a face on them, Jack, Queen, King. This is our ace. An ace is not a face card, okay? It's going to be super important because it's going to ask you, it's going to expect you to know this. So these are clubs, these are spades, these are hearts, and these are diamonds. So then one other thing that we have is that clubs and spades are both black, hearts and diamonds are both red, okay? And this is a total of 13 cards per suit, which is a total of 52 cards. So even if you're not a card player, you've got to know this because you're going to see all through stats, we're going to reference cards, and you've got to know what this looks like, okay? All right, so let's go over here to the next page and actually do some work. So it says, what is the probability that is red or a queen? So here's what I have. So I have this OR. So I'm going to write this as a statement first. So probability that it's red or a queen. Okay? This means I want to know the probability that it's red. And I'm using R for red and Q for queen up here. Plus the probability that it's queen. Now, I might have some overlap, so I'm going to subtract the probability that it is red and a queen. Okay, so if I look at this, look at this little card cheat sheet if you need to. So probability that it's red, I have 26 out of 52 cards that are red. Okay, so I have both my hearts and my diamonds are red. And then probability that it's a queen, I have 4 options that it's a queen. So probability that it's a queen would be 4 out of 52 minus the probability that it's red and a queen. So I'm going to subtract 2 out of 52. Okay? So when I do the math on that, I would have 26 plus 4 minus 2 divided by 52 cards. So my probability is 0.538. Okay? The next one, I'm going to say A for ace and king for king. So probability that it is an ace or a king is the probability of an ace plus the probability of a king minus the probability that it's an ace and a king. And y'all, this is required on the AP test. If you just write your values down, you will not get credit on a free response question. All right? So I know that this just might seem like it's repetition of this, but you've got to have this written down. So probability that I have an ace, I have 4 out of 52 aces, and I have 4 out of 52 kings, and I have 0 out of 52 that are aces or kings. So in this case, this part I can just ignore. So I have 8 divided by 52, which is 0.154, and this is mutually exclusive. I can't have an ace and a king at the same time. Okay, and I guess I didn't answer this question over here. This is not mutually exclusive, and it really is. It's really because of this guy right here, right? It says I can have both. Okay. I'm going to go ahead and pause this, and I want you to go ahead and do these next 2, and then come back and check your answers. Okay. This one was pretty easy. This one's a little more difficult. So, probability of odd. I used the word odd and not an O because I didn't want to get that confused with the 0. This number 16 over 25, it's important to know that an ace is not a 1. So this is not odd, it's an ace. So sometimes people get the ace and the 1 mixed up. You don't count it as a 1. I know sometimes when you're actually playing cards, we count it as a 1, but it's not. And so when it's black and odd, we're counting these 2, so 3, 5, 7, and 9, and that's where the 8 comes from here, right? So make sure you didn't count that ace as a 1. All right, next question. All right, you were interested in how many students at your school regularly eat breakfast. You conduct a survey asking, do you eat breakfast on a regular basis? Your random sample consists of 600 students at the school, and the results are in the table shown below. Okay, so if we select a student from random, what is the probability that the student is, so this is just random probability right here, that they are female. So probability that they're female is going to be 278 out of 600. Okay, and of ease of math, I'm not going to put this in the calculator right now just so that this goes a little bit faster. All right, so the next one, probability that it's someone who eats breakfast. So someone who eats breakfast regularly is going to be 300 out of 600, and this is an easy one. We know this is 0.5. Okay? Now, probability that it's female and eats breakfast regularly. So probability that it's a female and probability that they eat breakfast regularly. So if I go up here, female and eats breakfast regularly, that's this amount, 110. So I can pull this from the table, and I have 110 over 600. Now, this one's a little bit different. This has that keyword or. So probability that it is a female or eats breakfast regularly is going to be probability that it's a female plus the probability that they eat breakfast daily minus the probability that they're a female and eat breakfast daily. Well, I guess I'm going to have to go over here and do this number. Well, no, I'm not. We're good. So that's what this is. So I didn't write it this way, but this is the probability that they're female and eat breakfast. That's what this is saying. All right? So probability that they're female or eat breakfast, that's this. So female plus breakfast minus any overlap. And the reason for this, again, this is because we have an overlap when we count the data. So probability that they're female, I had this value, 278 over 600, plus the probability that they eat breakfast regularly would be 300 over 600, minus the probability that they're female and they eat breakfast, so minus 110 over 600. So I've taken all of these individual parts and put it together. And so what this turns out to be is, let's just do this math real quick, 278 plus 300 minus 110 divided by 600, which is 0.78. Okay, so make sure what you'll see is it's going to go straight to this and or. Like very rarely, these are not AP level problems, but you'll go straight to the ands and the ors down here. Okay, all right, Venn diagrams. So I know that this is math, and usually we don't see a Venn diagram in math. We see them in English, but we're going to use them in math here as we understand intersections and unions. So a Venn diagram, we have a union and we have an intersection. And so what happens when we have this is we've got this sample space that's here, and we've got a few things that are going on. So we have, let's see, the box, I want to make sure I've got everything here. So if I have this total sample space, so my total probability of the whole sample space is going to equal 1. All right? So what happens is I'm going to have my probability here of A, and I'm going to have the probability here of B, and this is going to be the probability of A and B, and this is going to be the probability of not A and probability of not B. So A happens here, A and B is the overlap, probability here, and then this is a complement, probability of A complement, so not A and not B. Okay, and then we know that this entire sample space is going to equal 1. So when we have a union, that is going to be our OR. And it's going to be that the probability that either or occurs. And again, when we use or, we're going to use this U symbol. When we have an intersection, this is going to be our and we just showed that up here, right? Here's my intersection, here's my and that I have here, and that's going to be the probability that they occur together, or as we've been saying, they overlap. And we use this upside down kind of N without the lip on it, okay? So if we look at what's happening here, what I have in this scenario is I have all of probability A and all of probability B and the overlap. So we would say that this would be an example of the probability of A or B. So this is my or example. It can be all of this or all of that. This would be an example of just the overlap. So this is the probability of A and B. So this is my and. Now this one is interesting because this says that A is not shaded in. So this is the probability of not A, right? It's everything else, including the probability that it's not going to happen at all. So we would say here that this is the probability of A complement. All right, now this last one, I can't have A and I can't have B. So it's what's happening on the outside. And I've already done the sneak peek up above, but this is the probability of not A and not B. So I would write this as the probability of not A, so A complement, and not B, B complement. All right. Now, this is just something that I thought was a good example of what we just did up above, just showing this again. So that's all that part is right there. All right. Okay, so let's go down here. So now we're going to shade the probabilities for the following notations. So these are not notations that I had given you. So what this is saying is the probability of A and not B. So this is A and not B. So if I want the probability of A, that would be this side, right? But not B, so I can't have this overlap region. So probability of A and not B would be just this guy. All right? So this one says probability of not A or B. So not A or B. Now remember, the difference between and or, this can be or both. So with my or statement, it can be either or, right? So and means both of those have to be true, or means not this or not that. So in this case, I have not A, so I can't have A, but I can have B, so I'm going to have all of this for B. But if I say not A, well, what else can be not A? Not A can also include all of this region. So I can have this region that's all out here. That would be my not A. Or B, which would be all of my B region. Now, it doesn't matter that this is overlapped, because if it's overlapped, it's still included with B. Okay? Now, this one says not A or not B. So if it's not A or not B, the easy part is what happens out here. Okay, that's easy. We know that that's not A or not B, but we also have this region in here because this is A and B. Actually, hold on. That's not true. It's going to be or. So it's going to be the opposite of that. So don't, hold on. I'm going to change this because I don't want there to be confusion on this. Now that I think about this, I'm going to fix it real quick. Hold on, I'm going to pause this while I fix this. Okay, that's super goobered up, but that's okay. So if it's not A, it can be B. If it's not B, it can be A. And this is or, so or is or both. So it's going to be this part of it and this part of it. So the part that's good is this in here. That's going to be not A or not B. Now, here's why. Here's why I can do this. It's not and, it's or. So I can have not A. So not A means I can have B and everything on the outside. Or not B, which means I can have A and not everything on the outside. But I can't have the overlap region because the overlap region would be A or B. Okay? So this part says not A, not B. Well, that's this region here, which is both parts. Okay? All right, sorry about that. Let's go down here. So, in your stats class, you're interested in exploring the taste preferences of your classmates. You have two tastes, sweet and salty. 25 students were asked if they prefer both, only sweet, only salty, or neither, and we came up with this two-way table. So, let's go ahead and fill out this Venn chart first. And I'm going to say that sweet is A and salty is B. It doesn't tell us here. Oh yeah, it does. Let A equal sweet and B equal salty. So if these are my sweets, then these are my salties. So that's how my two-way table goes. Okay? So if I want to look at yes, sweet, I would have 17 total people here. Yes, salty would be 13 people. No salty would be 12. And no sweet would be 8. So I'm looking at my marginal data right here. And so if I add all of these up, I have the 25 students. So let's figure this out. If A is sweet, I'm just going to put this over here, and B is salty, then the amount of students that I have that are just salty, so if they're just salty, I'm going to have 6 students who are salty and sweet. So this group here of 6 students are both sweet and salty. So that's easy. That goes right here in the middle. If I have students who are no salty and no sweet, that would be 1. That's my student that's out here. He doesn't like sweet or salty. So if I like students who are just salty, yes, salty, well, I've already accounted for 6 of them, and there's 13. So that would be 7, which is the 7. Okay? And if I have my sweet group right here, I have 17, but I've already counted for 6 of them. So the ones that don't like salty, that would be this number, which is 11. So I can take this data and I can put it in a two-way table, and it's going to help us as we go through this. Okay? So all we're doing is we're looking at the data to find the probability. And just because we're new to this still, this is my and this is my or. Okay? So this is saying and probability of A and B. So A and B is an intersection. So probability of A and B is this value of 6 right here. So I'm going to have 6 over 25. Okay? Now, this says to interpret. So I'm going to interpret this first one, and then we're going to kind of see just to save time. So if I have 6 divided by 25, it's 0.24. So my interpret, so it says find and interpret the following. This would be the probability a student in the class likes both sweet and salty is 0.24. Okay? All right. This one is an or. So we know our population for an or is going to be probability of A plus the probability of B minus the probability of A and B. So the probability of, sorry, my camera's glitching out here. I tried to fix it just now. So my probability of A is going to be 11 over 25, plus my probability of B, which is going to be 7 over 25, minus the probability of A and B, which is going to be 6 over 25. So let's talk about this for a second. So here's my probability of A or B. Now, what we know here is that we want the probability of A, which would be the whole thing, right? The probability of B, which would be the whole thing. And then it says the probability of A and B. Now, this is just saying A or B, right? So or can be and or. So this can be both. Remember, when we have it can be the probability of both. Well, in this case, I'm not going to subtract this 6 over 25. I'm going to go back up here and I'm going to add this. Because I can have this probability here in the middle of 6 and 25. So if I add this up, 11 plus 7 plus 6 divided by 25 is 0.96. Now, let's think about this and see if it makes sense. So this is asking us the probability that they like sweet or the probability that they like salty. And my overlapping part right here is at 6. Normally we don't count the overlapping part, but when we did our Venn diagram, we did calculate the overlapping part. And so because of that, it's 0.96%. Well, that makes sense because there's only one student that doesn't like sweet or salty. Now, if I was to go over here and look at this graph and pull the numbers off of this table versus the Venn diagram, I would have to go back to my ands, right? So don't get jammed up if you take a frequency table and you turn it into a Venn diagram. In this case, we needed to include this middle section. If I look over here, I would have to subtract out those numbers to get everything that I needed, right? And so let's keep going here, see if this makes a little more sense. So probability of A and not B. Probability of A and not B. Well, the probability of A and not B is just going to be 11, right? It can't include this 6. So I would have 11 over 25. Okay? This says not A or B. Now this is not A or B, this is not A, but it could be B. So I could have overlap here, right? It's okay. So probability of not A, if I look at my graph, is going to be 7 plus 1. So probability of not A is 7 plus 1 over 25, right? My probability of B is going to be 7 plus 6. So my probability here is going to be, I'm going to do 6 plus 7. I know what I did there. Over here. So what I have at this point is I have 8 plus 13. Well, now the overlap has mattered because now I've counted this value of 7 twice. I counted it here and I counted it here. So what this needs to look like is 7 plus 1 plus 6 all over 25. If I add this up the way that this is, and I have 13 and 8, then I've counted the 7 block twice. So my probability here is going to be 14 over 25. Okay, so this says the probability of A, and I have an or, so probability of A or not B. So my probability of A is going to be 11 over 25. And my probability of not B is going to be 6 plus 1. All right, so this is 11 plus 7. So 18 divided by 25, 72. Which is 0.72. Okay, now I'm going to show you this the other way. So if I do this, this is the same thing as 11 over 25, probability of A. My probability of B happening here is going to be, or sorry, not B, is going to be 11 plus 1. So it's going to be plus 12 over 25. And then I have to have not, so not A. So minus, oh, sorry, I counted this wrong. This should be 17. Probability of A is going to be 17. Probability of not B is going to be 11 plus 1. But I've already counted this 11, so minus 11 over 25. And when I do this math, just so you see this, 17 plus 12 minus 11 is 18, which is 0.72 again. Okay, last one, which I think is the easiest one. This says not A and not B. Well, if it's not A and it's not B, I only have one choice. And that's this guy. It's not A, it's not B. Okay?